All right, so we have two more. You guys ready? All right, so we have two more sections for derivatives. We have linearization and then related rates. So linearization is what we're going to be doing is like kind of approximating certain things using the tangent line, right? So like right off the top of your head, like could you tell me what the cube root of 70 is? No, right? So it's a little difficult. But what we're going to try and do is we're going to try and come up with a method so that we can use a tangent line to help us figure out what exactly that value is. All right? So we're going to start using this concept, what's called locally linear. All right? So if you have say you're looking at that picture there that I have for you, which is the cube root of x, right? And this idea of locally linear is that when you have a tangent line that intersects the curve, right, they're so close to each other that we could assume that the values of this function are the same or very close to the values of the tangent line, right? Does that make sense? So the line on the top here would be your tangent line, and then the line on the bottom would be your, that's the curve of the cube root of x, right? So they only actually intersect at this point right here, which is 64. But what I can do is I can use the tangent line to help me kind of approximate values a little bit to the left and a little bit to the right of this point right here, right? So I know what the cube root of 64 is, okay? And what I can do is I can use that tangent line to help me kind of figure out values a little bit to the left and a little bit to the right. All right, so what we want to do is we want to come up with, they're going to ask you, okay, figure out the cube root of 70, right? You're going to have to figure out, okay, what's my function, right, which is the cube root of x, and you need to figure out what exactly is what's called your center. And your center is something that you definitely do know, right? And what we're going to do is write the tangent line at that center and then use the tangent line to come up with that approximation. All right, so that's what it means to be locally linear, is that the f of x and the tangent line have the same or very close values to one another. When I get a root. One. No. All right, so what we're going to do is, again, we're always going to try and figure out what our center is. We're going to call that C for easy purposes. And then we're going to use that concept to help us come up with the cube root of 70. Not necessarily close to 70, but one that is like something that's like you can figure out. So if I were to say like figure out the value of 2.01 squared, you could use 2, right? And then based off of that tangent line, you can help figure out what 2.01 squared is. So just something that's like easier, and then using that particular tangent line to help you figure out something that is a little bit more difficult. So approximate the cube root of 70 by using a tangent line centered at 64, and then determine if it's an under or an over approximation. Okay, so again, we're using the cube root of 70, which is a little bit difficult to kind of come up with off the top of our heads, but we do know that the cube root of 64 would be what? 4, right? All right, so what we need to do is we need to kind of write ourselves a tangent line. All right, we're going to use our center, or something that is easily figured out. In this case, our center would be 64, because our function is the cube root of x, or x to the 1/3. All right, so I need to write my tangent line. So I have a point already. My point already would be 64, 4. Now I just have to figure out the slope of my tangent line, which I get from the derivative. Okay, so f prime of x would be what? Right. And then if I rewrite that, I have 1/3, I'm sorry, I have 1 over 3 times the cube root of x squared. All right, I want to rewrite it like that because I need to figure out exactly what the slope is here at 64, or at x equals 64. And then this is the same thing as 1 over 3 cube root of x squared. So I can use either one. The reason I'm doing that is because we're going to need to figure out what exactly is f prime of 64. We need to figure out what the slope is at 64. So if I use this, you're going to have to square 64, and that's going to get hard. But you can figure out this is a little bit more easier to use. Right? So f prime of 64 would give me what? I have 1 over cube root of 64 squared. So we know the cube root of 64 is 4. 4 squared is 16. 16 times 3 is 48. Okay, so we have 1 over 48. So that is the slope of our tangent line. So now what we want to do is write our tangent line. And that would be what? Y equals, what was the y value that we found? 4, right? Plus 1 over 48 times x minus 64. Okay. All right, so again, any value a little bit to the left or to the right of 64 is going to have very similar values to what my tangent line has. Okay, so since we're looking at 70, I can plug now 70 into my tangent line, and that should give me a pretty close answer to what the cube root of 70 is. All right, so if it's looking for tangent line approximations, what we want to do is we want to give this a specific name. So we're going to call this L of x for linear approximation. All right, so we just have to give it a name. All right, now it's asking for the cube root of 70, right? So we're really trying to figure out what exactly is f of 70, right? So we're going to use the tangent line to help us figure that out. So you need to write f of 70 is approximated, so you use your squiggles, and then we're going to use L of 70 to help us write that. And then, so this is saying that you're using the tangent line approximation, which we found to be L of x. We're going to use that to help us approximate what this value is. No, it'll be very, very close. The only place where we would get the exact value would be at 64, right? Because the tangent line and the curve, they share the same value at that point. So anything to the left and the right, it's going to be a little bit off, but not by much. So I have 4 plus 1/4 times 70 minus 64. So that gives me 4 plus 1/4. Where did I get 48 from? Oh, right. Sorry. Okay, so I have 4 plus 6 over 48 would be what? 1 over 8? And then that would be roughly 4.125. That would be the answer. So well, I mean, you're not always going to have the calculator available, so. All right, so that's what we found. So roughly the cube root of 70, that's what we approximated with the tangent line, came out to be 4.125. All right, now the second question is what? Is this an over or an under approximation? Now this is where you kind of need to look at what the graph's going to look like. So if I'm looking at the cube root of x, what's the concavity of that graph for x values greater than 0? Concave down, right? So cube root of x is concave down for all x greater than 0, right? So anytime you have a function that is concave down, your tangent lines are always going to be above the function. Okay, so if the tangent line is above the function, right, your tangent line value, which we just found, is going to be a little bit higher than the actual value. So it's an over approximation. All right? So we could say f of x is concave down for all values of x greater than 0. So L of 70 is an over approximation. Now, if it was concave up, where do you think the tangent lines would be? Below, right? And then it would be a under approximation. All right, so if you plug that into your calculator, what do you get? Cube root of 70. All right, so the calculator says that it's 4.121, and we got 4.125, so we were pretty close. Yeah, so the tangent line is going to give you a value that's a little bit bigger than or a little bit less than what the actual value is. Because that's based off the the concavity, and then anytime you have a concave down function, all your tangent lines are always going to be above the function. So if they're above the function, like this value is going to be a little bit more than what the actual value. Exactly. Yes. Right. Yep. Yes. You just would probably have to do it with the exponent, like 70 to the 1/3. All right. So